Hi, welcome back to the operators of Java. So today we will learn how to implement relational and logical operators. Last day we have seen the various implementations of arithmetic operators and others. So today we'll try to do once again with the relational and logical operators. So I'll show you some practical over here. So let's have a look. So we'll start BlueJ, and now after this we'll try to create a new class, maybe first relation, and here I'll try to show you with a real world example. So let's make it bigger. So as we have discussed, first relation, first relation means first relational operator. So here let me give some kind of documentations about this project. We are going to use relational operators in this program. Okay, so who is the author of this program? You must write your name and don't forget to give the date or the version. Since you are not familiar with the versioning system, you can give the date. It is also an alternative method. Now let's start a class, public main function, and here we go. So what we will do here, I'm trying to create a mock-up so that it will say whether you are pass or fail. So what I'll do, I'll try to get the number, okay, maybe the total or the subject marks. Okay, so what is the subject mark? Maybe instead of more subject mark, let's keep mark. It will be very bit easier. So in the parameter, I'm collecting integer variable or integer value from the user, and now I am going to use the relational operator like less than, greater than, equal to, greater than, equal to, like this. Okay, so what I am going to do first, if mark equal to 80, then it must display system.out.print. So system.out. Here also we are using the dot operator. I'm going to write Congo. You got star mark. Okay, so here I have used to equal to sign to check the equality of the mark and 80. We have a literal a constant here which is 80, and we have the variable mark which is dependable upon the user input. It's a definitely parameterized input. Now also I'm going to define that if the mark is greater than 40, okay, or greater than equal, we can use greater than equal to 40. So what I am going to do, uh, I'll try to display that you pass. Awesome, you have passed. Okay, otherwise we can make like this, else if it is not, then sorry, you have failed. Sorry, you have failed, and try again. Okay, so it is a very real life example of a marks where I am just showing if the number is not only 80 or greater than equals to 80, then you got star mark, or if you are greater than 40, then awesome, you have passed. And also if you got less than 40, then definitely it will display you have failed, and try again like this. So let's compile and close it. So if you run this program, if you put any value like 55, it is only showing awesome, you have passed. Or maybe if I got only 20, so it will say sorry, you have failed, and try again. And now if you got maybe 85, so it will say congratulations, you got star mark, as well as it will also say awesome, you have passed. So this is the example of how we actually use this kind of relational operator, greater than, less than, greater than equal to, less than equal to, or not equal to. Okay, so here it is the most use case. Now in the next program I'm going to show you the next thing, which is already the relational operator. Now we are going to jump into the section of logical operators, where we have and, or, and not. So before starting this, I want to say something like, if it is a if it is a case of and, both condition must be true. Okay, if only one condition is true and another one is false, the ultimate answer or the result will be false. So always remember, for AND gate, if the both conditions satisfied, that means if the both conditions are true, then only it will give you a result of true. If both conditions are false, or maybe one condition is true or one condition is false, then it will give you the result of false. Also, I'll show you how it is actually working just after writing the program. And in the case of OR gate, you need to pass only one true. That means if only one side is true, the answer will come true. It doesn't matter whether the both are true or not. If one side is true, the both in the result will be true. But the last time we have NOT gate, which is a kind of negation also. Maybe if you are passing 1 with a NOT, it will become 0, and if you are passing 0 with a NOT, it will become 1. So this is the case for NOT gate. So now let's start and let's see with the program. Let me create a new class, maybe first logic, and here I'll try to explain how these logical gates are actually working. Sorry, public class first logic, and here definitely I'll try to create some documentation. This is a program where I want to show how logical operators are working. So let's put the date. Today is the 21st of August 2020. Okay. You can write anything, any name here. It doesn't matter what you are doing here. Okay. Put any name according to your wish. Now maybe I'll try to get integer a comma integer b, two integer variable here, and what I'll try to do, I'll try to use them. Okay, how I am going to use them. So maybe let's say instead of integer, let's take boolean. It will be little bit easier now for now. Okay, so system dot out dot, so I'm going to directly print the thing. What I'm going to print, I'm going to print the same thing here. I'm going to write A and B. So let's see if I'm writing A and B here, A and B, what is the result? Similarly, I'll try to do with OR. Okay, and also I'll try to do it with the NOT. So here let me display or, okay, and here maybe not sign, one not sign. So here I will write not A. Okay, so whatever is the left side, I am going to show you the same thing I have written here. If you compile, close and see, if you run it, it will ask you for the 2 boolean value. So if I am giving true and second one is false, so if you hit, so the A became true and B became false, you see. So A and B, that means true and false, became false, because I told you if it is an AND, the first one is the AND gate. If it is AND, both needs to be true, otherwise it will give you a false output. But for the OR gate, only one side is true, that's why it is giving the output of true. And you know the for the A I have given input of true, but since I have given a not sign here, you can see not A, that means true became, that means not true, that means it's false. Okay, so it's just like this, not true, so it's became false. So this is how this logical operators are working. Let me write one more clear example for you. So I'm going to create another one function with my name. Okay, you can put your name also here. We have complete freedom, integer a comma integer b, and I'm writing if a is greater than b. Okay, or maybe let me take three variable. So if a is greater than b and a is greater than c. So this is the thing I am going to prove here. A is greater than b and a is greater than c. Okay, so let's see, if any number it comes into this a, b and c, maybe this side also it will generate a true or false proposition. This side also answer will come either in true or false, because these are the propositions. So maybe a is 1, b is 2, so a greater than b, no. Maybe c is 3, a greater than, that means 1 greater than 3, no. So in this case both became false, so the ultimate answer will come false. So now let's see it in the action. Maybe here I'm giving 1, 2 and 3 as I told you. So but then the answer will be false, because see, 1 is greater than 2, no, so false. And 1 is greater than 3, no, that means false. So false and false, the ultimate result becomes false. So similarly, let me put the same logic for OR. Okay, so I'll show you how OR it works. Now if I hit this one, maybe this one is 5, this one is 6, but this one is 2. Okay, so if you hit enter, the first result it is false, because 5, 6 and 2, if 5 is greater than 6, no, but 5 is greater than 2, yes, but for the AND gate you need both to be true, that's why the result is coming false. But the second example, a greater than b or a greater than c, so in this case a greater than b became false, but a greater than b became true. So since you are getting one input as a true, the ultimate result it is coming true. So this is how the logical operator works, and using the logic we can implement something like this. Maybe let me write a function with the compare. So I'm going to integer a, integer b and integer c. I'm going to write a function to compare three numbers. Okay, if a is greater than b and a is greater than c, so here it is a use case. system.out.println a, that means a is greater. Okay, else if b is greater than a and b is greater than c, then b is greater. Else we can write c is greater because only c left. Okay, so using this logical operator and relational operator, I have created a compare function which can able to compare three number and it can display the greatest number. Okay, so let's close and run this program. Maybe 20, maybe 6, maybe 55. So it is telling 55, c is greater. Maybe let's put something with the b, 5, 55 and 6. So it's telling 55, b is greater. Or maybe maybe 5, then 1, then 2. So it's telling 5, a is greater. Okay, so this is the actual use case of relational and logical operator in Java. So I hope you have learned something about logical operator and relational operator and how to use them in the programming. Okay, so if you have any questions, please write down in the comment sections and let me know about your thought. Okay, so thank you for watching this video. Thank you. Bye bye.